Investigative Genetic Genealogy, that's quite a mouthful actually, or IgG, offers an exciting new opportunity to help law enforcement give names back to unidentified human remains and help solve criminal cases. You'll have seen a lot of this on TV lately. Since the first high-profile case was solved in 2018, well over 1,000 cases have been cracked using IgG. Canada has its own share of successful case solves, and there is much discussion, controversy, and numerous questions around this new way of generating leads in cold cases. Today, Marie Palmer is with us. Marie is a Canadian accredited investigative genetic genealogist with numerous case solves, and she's going to give us an overview of IgG and walk through a Canadian case study about one of her first successful identifications. Additionally, she'll discuss how people can help and get involved. As a professional genealogist, Marie has helped dozens of clients to extend their family trees, solve mysteries, and find biological family. She has worked with legacy tree genealogists since 2022 and has been generating leads in cold cases using genetic genealogy through the British Columbia Institute of Technology. It is my pleasure to introduce to you this morning Marie Palmer. Welcome, Marie, and thank you for joining us to enlighten us on IgG today.
Thank you so much for having me. Thanks everybody for being here this morning or afternoon, wherever you might be. I have been working as an investigative genetic genealogist for several years now. All of that work that I've done as that sort of genetic genealogist has been through the British Columbia Institute of Technology, otherwise known as BCIT, and that's here just outside of Vancouver in BC. They are an academic institution that has a DNA forensics lab. I had no idea that they even had that sort of lab before I started working with them, but they've been working with law enforcement agencies for many, many years now, and they've developed some very strong partnerships with those agencies and have been helping them to solve cases long before investigative genetic genealogy came along. So not only do they teach future forensic scientists, but they've been trying to move forward with the cutting edge technologies and have been making some great strides moving forward with this IgG work. So today I'm going to give you a bit of a high level overview of how this works, and we'll go through the first case solve that we had through BCIT. Any personal views that I express here today are my own. So BCIT knows that I'm doing these presentations, but any personal views are purely my own. So as Dan mentioned, investigative genetic genealogy is a mouthful. I don't want to keep saying that for the next hour, so I'm going to stick with IgG. You will sometimes hear it referred to as forensic genetic genealogy, FGG, or maybe even forensic investigative genetic genealogy, which is a bit too much, but that's also known as FIGG or FIG. It is essentially combining traditional genealogy research, which most of us have done here, with DNA test results, and many of us on this online today have taken those DNA test results. They're combining that together to help generate leads in law enforcement cases. So the types of cases that we are allowed to work on in the IgG world include unidentified human remains, suspects in eligible criminal cases, and sometimes now also helping with wrongful convictions. So if somebody who is innocent but is in jails currently and is looking for a new avenue to perhaps help exonerate themselves, IgG might be that new source for them to help them overturn their conviction. So I think most of us here know what traditional genealogy is. In a very simple form, we're trying to build out our family trees using that traditional documentary evidence. So census records, birth, marriage, death records, land records, whatever we can get our hands on that include a name of somebody that we're researching, that will help us build our tree. So we've been doing this for hundreds of years, really. But now we've also got something called genetic genealogy. And all that is really adding in a new source of information, which is our DNA test results. So I'm sure many of you have already done a lot of genetic genealogy, but just to give a little bit of history, it essentially was born around the year 2000 when a company called Family Tree DNA started offering a couple of different types of DNA tests that anybody could purchase. So those were the Y-DNA test and mitochondrial DNA tests. So anyone who is born as a biological male will have a Y chromosome. Biological males have Y chromosomes as well as an X chromosome. Biological females will have two X chromosomes, but they will not have that Y chromosome. So only biological males with that Y chromosome can take a Y DNA test. And what that'll do is it might hopefully give you some information about your direct paternal line, because every male will inherit their Y DNA from their father, who got it from his father, and so on and so forth. So that can be very helpful for that direct paternal ancestry. On the flip side, we have mitochondrial DNA. And everybody has mitochondrial DNA, males and females. And everybody, all of you, got your mitochondrial DNA from your biological mothers. And she got it from her biological mother. And so it's sort of the flip of the Y DNA in that it is following that direct maternal line. So anybody can take a mitochondrial DNA test and hopefully get maybe a little bit of information about that direct maternal ancestry. It took a few years, but there's a different kind of DNA that is available to us. So all of us are born, as well as our sex chromosomes, we also have something called autosomal DNA. And that is inherited in equal parts from both of our parents. So I got half of my autosomal DNA from my mother, and I got the other half of my autosomal DNA from my father. So in 2009, a company called 23andMe introduced a test that anybody could purchase to test their autosomal DNA. So when we hear about DNA tests in the mainstream media, most of the time they're talking about those autosomal DNA tests, and that's what 23andMe is, that's what Ancestry is. Ancestry started selling those kits around 2012. So anybody can take one of those tests, and that should fill in some information about the people in the middle of the tree that were missed from those direct maternal and paternal lines. So it can be very, very helpful for us for our genetic genealogy, because it's not just following this one direct line, but it could give us information about several different lines in our trees. So if you've already taken one of those tests, you know what they offer. If you haven't, here's a little bit of a background. They will include information about your ethnicity, so your background, your heritage. What's really, really helpful for us is the big long list of DNA matches. So everybody else who has taken a test at the same company as you, if they share DNA with you, they will show up in your list of DNA relatives or DNA matches. You'll also potentially get some health information, and that will vary from one company to the next. So ethnicity estimates, also sometimes referred to as admixture. What does that look like? You'll just get different companies will have different regions that they report on. Sometimes they name them a little bit differently. You'll get a percentage of where your ancestry is from. So this is mine from Ancestry, and my mother is French Canadian and has deep, deep roots there. So that's pretty accurate with the 48% French there. My father is born in England, and those numbers correspond quite well with his family tree that I've developed. Those numbers can vary a little bit from one company to the next based on the algorithms that they're using, as well as the different reference panels that they use. So don't sweat it too much if you see slightly different numbers from one company to the next. What you're looking for is just a general idea. This can be very helpful if you don't know anything about your ancestry, or you see something brand new and interesting and surprising in there, and that might give you some ideas to follow up on with your research. But as I mentioned, the most important piece for us would be that list of DNA relatives. So this is much more accurate than the ethnicity results. And what you'll see is a list of potentially tens of thousands of people in that database who share DNA with you. So you won't see everybody in the database, but you will see those who have also taken the same test and who share DNA with you. That list is sorted from those people who share the most DNA with you down to the least. So in this example here, I've anonymized the names, but both of my parents have taken the DNA test. So I share the most amount of DNA with my parents as well as with my children. So my parents will show up at the very top of that list. If my children had done a DNA test, they would also show up at the top of that list. We will see information about whether or not one of those DNA relatives or DNA matches, if they've also included a family tree, which can be helpful for us. We'll see information about how much DNA they share with us, and it will go down. So the next person, my parents at the top of the list there, the next person in line is my full sister. So she's the next person that I share the most DNA with, and then it drops down from there. So when we're working with genetic genealogy, we tend to like to work with those higher matches, but sometimes we are working our way down quite a ways down that list. We will never actually look at the tens of thousands of people in that list, but it's definitely helpful to go in there, see who you're related to, and maybe they've got some information that will help you with your own family tree. So this was really exciting for genealogists when it came out, and it did not take long for people to realize that adoptees could get a lot of valuable information from these tests. So we know that adoptees, if they're trying to find their biological family, often will run into these brick walls and they're not able to get the information they're looking for. But suddenly around 2010, they were able to purchase these DNA tests that gave them a wealth of biological information that they never had before. So if they were looking for biological family, they would have been hoping that maybe a sister or a brother or a parent had also taken a DNA test at the same company. And then right away, they would have had some information about their close and immediate family members. When these tests first came out and there weren't that many people in the databases, the results for adoptees were maybe a little bit more challenging because they would have more distant relatives who would show up. So they might get a first cousin if they were lucky. They might get second cousins or third cousins popping up. But those more distant relatives can still help them to identify perhaps their biological parents. And so a number of genealogists recognized this and started to develop strategies to help adoptees identify their biological family, specifically and hopefully their biological parents. So I've got a woman there named Cece Moore. I'm sure many of you have heard of her. She is recognized as one of the pioneers in this field and helped to develop those strategies. We use those same strategies in the IgG world. So it took a little bit longer, but around 2018, a few people had the idea that if adoptees, who are essentially unknown people biologically, if they can use these DNA test results in combination with traditional genealogy to determine their biological parents, then maybe we can apply the same strategies to unknown DNA samples that law enforcement cases have. And so a couple of women by the names of Margaret Press and Colleen Fitzpatrick, who later went on to form the group, the DNA Doe Project, they teamed up with law enforcement to see if they could do this. And they worked on a case. At the time, it was a 37-year-old unknown woman who had, well, the case was 37 years old. She was about 21 years old at the time when she had been murdered in 1981. And law enforcement tried as hard as they could to identify her, but were unable to do so. And as a result, were never able to find her family and inform them of her death. So the case went unsolved for 37 years. And Margaret and Colleen were able to work with law enforcement. They extracted some DNA from this Jane Doe and were able to upload that into the genealogy databases. Margaret and Colleen were then able to look at her results, which included the ethnicity results and the list of all the DNA relatives, and they were able to solve that within a few hours. They were able to come up with the name of Marcia King. And at that point, law enforcement started to realize, like, hang on a second, we have potentially some new technology that can help us solve lots and lots of unknown cases here. So this is a really, really big deal. But it was overshadowed by another case, which I'm sure many of you have heard of. So another woman, right around the same time, Barbara Ray Venter, had the same idea, and she teamed up with law enforcement to work on a criminal case. This case was called the Golden State Killer case. And it was a very, very high profile criminal case in the 1970s and the 1980s in the San Francisco area. An unknown individual committed a series of murders, well over 13 murders, probably well over 50 violent rapes, burglaries, you name it. It was terrible, terrible, scary time. The law enforcement at that time devoted millions of dollars to this case to try to solve it. And unfortunately, were not able to do so. So it eventually became a cold case, and the identity of the Golden State Killer went unknown for decades. So Barbara Ray Venter got this case. They were able to upload his DNA sample to the genealogy database. Took a little bit longer than Margaret and Colleen's case, a few months, I think, but they were able to come up with a name for this potential suspect of Joseph James DeAngelo. They passed that name on to the police department, and they were able to track him down. He was still alive. And using the traditional law enforcement methods, they were able to prove that this was their suspect. So he went to court, he was convicted, and he is now currently in jail, which is a huge, huge relief. So this really blew open the doors for IGG. Suddenly we could see that there was great potential for solving the hundreds and the thousands of the unknown, the cold cases that were out there. But of course, with any kind of new technology, people get really, really excited. It takes off, and takes a little bit longer for guidelines to follow and accompany that to make sure that we're doing things in an ethical manner. So there were some bumps in the road at the beginning. But since then, some policies, some really good, strong policies have been developed. So the US Department of Justice developed an interim policy several years ago. It is definitely worth a read. It's not that long. Gives some good background about IGG and some of the guidelines for us as practitioners that we should be following. Last year, the Ontario came out with their own set of guardrails for police use of IGG, and that is an excellent read. So I've also included this in the handout that you should have available to you. That gives a great background of IGG and some of the challenges that we have, how it works, and what we're hoping to see as we move forward. So at this point in time, we have well over 1,000 cases that have been solved worldwide. I think that number is really quite conservative now, and it's hard to know what that number actually is because a lot of agencies aren't publicizing their case solves. So PCIT, for example, has not really been publicizing any of our case solves. I think there are just a couple that have been mentioned in a couple of blog posts, but they're really quite under the radar. And most of the reason for that is because the families of the identified individuals would prefer that these are not publicized. So yeah, 1,000 cases is probably quite low at this time, but that's a significant number in just 8 years. So it's quite exciting. The last point there, the Investigative Genetic Genealogy Accreditation Board, they also have come out with guidelines for us to follow, as well as a very, very rigorous exam to become accredited in this field. That is also worth a look if you're interested in this field. If you go to their website and look at the exam study guide, it's got a great breakdown of all of the details that we should be aware of and know as we're working in this field. So if anybody has questions about the exam, feel free to get in touch with me. I did the exam last June, I believe, and it is a really tough one, but I really enjoyed the process, and I'm happy to say that I passed. So I am very, very happy to give some guidance if anybody's looking to take that exam. So let's talk about some of the guidelines around IGG. So as I mentioned earlier, there are specific cases that are eligible, most are not eligible. So for example, if somebody were to break into your shed and steal a bike and they left behind a small amount of blood as they did that, the DNA from that blood sample would not be eligible for IgG work. It is not one of the eligible crimes for IgG. So I've listed there on the screen the eligible crimes that can work with IgG at this point in time. So we're looking at some of the most violent ones: homicide, non-negligent manslaughter, aggravated rape, et cetera, et cetera. We work on unidentified human remains as well. And the last point there is, before we consider IgG work at all, the case has to go through traditional law enforcement methods first. So IgG is almost always that kind of last dash effort. They will work through their tried and true methods to begin with, the methods that have been proven in court and that work. And if they are not able to come up with any leads, at that point in time, they will consider IgG work. Now, I've included here guidelines for the eligible DNA testing databases. The guidelines merely say that we can only work with the databases whose terms of service allow us to work with them. So out of this pie chart here, we've got some of the major testing companies. Most of us have heard of Ancestry. They've got about 27 million people who have tested with them. 23andMe have about 15 million people. MyHeritage, roughly 10 million people have tested there. Living DNA is one of the newer, very small ones, roughly 300,000 people in there. And then Family Tree DNA has just under 2 million people who have tested with them. So out of these databases, the only one that will allow access for IgG work is Family Tree DNA. So you can see there, if we had the opportunity to upload to all of these databases, we'd be able to compare our unknown sample against almost 50 million people. And our odds then of finding really close relatives would be really quite high. But because we are only allowed to look in a really small database, the odds of finding close relatives is greatly reduced. But still, we can work quite well with a database of that size, and obviously lots of cases have been solved using these smaller databases. Now, Family Tree DNA is not the only database that we have available to us. There is another one called GEDmatch, and I'm sure some of you have worked with GEDmatch. It's a little bit different in that you cannot purchase a test from GEDmatch, but if you have taken a test with Ancestry or 23andMe, what you can do is download your DNA test results, sometimes referred to as a raw data file, and you can save that to your computer. It's not a file that you're going to go look at and read. It's just got a bunch of numbers and letters in it, but you can take that file and then upload it for free to GEDmatch. You can also upload it for free to Family Tree DNA. And so the 2 million people that are in GEDmatch right now have done just that. They have tested elsewhere and then upload their results for free to GEDmatch. So now we've got some additional people that we can compare against because we are allowed to work with GEDmatch. I should say here is that when you upload your DNA samples to Family Tree DNA and GEDmatch, you have the option to opt into law enforcement work or opt out of law enforcement work at both of these databases. I don't know exactly how many people have opted into law enforcement work at these databases, so we are actually working with numbers that are smaller than the 1.7 million and the 2 million that we see there on the screen, because not all of those people have opted into law enforcement work. At Family Tree DNA, if you have opted out of law enforcement work, we will never see you. You could be the parent of our unknown person, and we will never know about it unless you have opted into law enforcement work. So if you've already have a DNA sample at Family Tree DNA or at GEDmatch, do have a look at that and have a good close read of what that means to opt into law enforcement work or opt out of it, and see how you feel about that, and consider opting into law enforcement work. And finally, there's one newer database that we can work with, and that's called DNA Justice. This is a nonprofit organization that was built purely for IgG work. So you can upload your DNA sample for free to DNA Justice, the same way that you can with GEDmatch and Family Tree DNA. But it's a little bit different in that you can't go into DNA Justice and see who else you match with and try to do some genealogy in there. If you upload to DNA Justice, it's purely to help with IgG work. And so at that point, what I can do as an IgG practitioner is I can go and see my unknown person in there and see who they relate to and hopefully make some progress on that case. So the numbers there are quite small. We have just over 7,000 people in there who have tested. I know some cases have been solved in there, even with small numbers like that. But obviously, we would love to see those numbers get bigger. So if this is of interest to you, please have a look at DNA Justice, read their terms of service, see if you're comfortable with potentially uploading your DNA sample there for IgG work. It would be very, very helpful for helping to solve cases. So let's talk about the process from a very high level point of view to begin with, and then we'll dig deeper into how we actually do the genealogy part. As I mentioned, every case first has to go through traditional law enforcement practices to begin with. And part of that, if it includes DNA work, will include looking at a DNA sample, potentially from unidentified human remains or an unknown suspect sample from a crime scene. They will analyze that sample in their labs, and they've been doing this for a couple of decades now. So what they're doing is they're analyzing those DNA samples using and trying to turn it into something that we call an STR profile. And STR stands for short tandem repeats. So they're basically analyzing the DNA and they're looking at repeating patterns across that genome and turning it into this digital profile that they can then upload to law enforcement databases that have been around for quite some time. So in Canada, we have the National DNA Databank, and I want to be very clear that these are not genealogy databases. I'm not talking about IgG at all right now. So this is all before the IgG work can begin. So law enforcement will traditionally take that STR profile from the crime scene or wherever, and they will upload that to a national DNA databank in Canada, or in the States, there's something called CODIS, which is the Combined DNA Index System, so it's something similar. Those databases contain hundreds of thousands of DNA samples from convicted arrestees. They might contain samples from other crime scenes, even if they're unknown. And what they're hoping is they're trying to find either a direct match or a very, very, very close relative in that database. And those databases have been very, very useful for solving cases traditionally for a long, long time now. But often there might not be any kind of direct match in there. So if they're not able to come up with any suspects or any leads, then they might consider IgG work. And if they do go ahead with IgG work, it means they have to go back to the lab because the STR profile that they previously created from that DNA sample does not work in the genealogy databases. So they go back to the lab and they analyze that DNA in a different way now. And what they're trying to do now is create a different kind of profile called a SNP profile, or SNP, which stands for single nucleotide polymorphism. So in this case, instead of looking at repeating patterns across a genome like they've been doing traditionally for a long time, now what they're going to do is they're looking at specific locations along our genome, hundreds of thousands of locations, and they're trying to turn that into a SNP profile, which is a digital file that can then be uploaded to our genealogy databases. And those hundreds of thousands of locations are then compared to everybody else's SNP profiles in those genealogy databases. So it's not a cheap process. All of this lab work can be quite expensive. But once they have that SNP profile, law enforcement can go to Family Tree DNA and or GEDmatch and or DNA Justice and potentially upload that file. Now, whenever you upload your own DNA to GEDmatch or Family Tree DNA, you can do it for free. You could create some kind of random alias if you wanted. You don't even have to use your real name. They will never go and try to ensure that you are who you say you are. But that's very, very different for law enforcement. So law enforcement has to flag themselves as law enforcement and that this is a law enforcement case. They have to ensure that it is an eligible case, and then they have to pay the fees before they can upload the sample. And those fees are not cheap. So uploading a law enforcement sample to GEDmatch is $1,000 US. Uploading to Family Tree DNA is $1,400 US. Luckily, DNA Justice, because it was created for IgG work, they're trying to do this and keep the costs down to basically nothing. So that's another reason why we would love to see DNA Justice grow, because it doesn't cost us anything to upload samples there. So again, if you're interested in this, go and have a look at DNA Justice and see what you think. So once we get the DNA sample into the genealogy databases, that's where the genealogy starts. So this is where I come in. I have nothing to do with the previous part of this. The team at BCIT is incredible at their jobs and they know all about this. I always love to go in and see them, but it is definitely beyond me. So once that profile is in the genealogy databases, this is when I can go in and do my work. And hopefully I can come up with a lead. So using the information that we have for that suspect or that unknown person, my goal is to potentially find a name for that person. Sometimes I'm able to do that, but sometimes I'm not able to. Sometimes I can only get to potential grandparents for that unknown person, or maybe even great-grandparents. But those are leads, and those are often very good leads, and I can pass that information back on to the law enforcement agency to follow up. Even if I come up with a name, a specific name for our potential unknown person, and even if I feel really, really confident about it, I will never, ever say 100% this is your person, because there might always be something else that I didn't see. There could be an adoption that I'm not aware of, or there could have been an unknown twin that I'm not aware of. There are a lot of reasons why I would never be able to say with 100% certainty that that is our person. And that's why no IgG practitioner will ever say, I have solved this case. What they will say instead is, we've generated a lead and we pass that lead on to law enforcement, and it is up to them to then follow up and prove that it is the same person using their traditional means. So in the case of unidentified human remains, they'll follow up by trying to find immediate family members. So perhaps a parent or a child or a full sibling. And they will meet with that person and try to get a DNA sample from that person. That will be the traditional DNA sample that they've always used, so an STR sample, and they'll compare that sample against the sample that they have. And that is how they end up proving that case. So sometimes IgG practitioners, we sometimes make the mistake and say, I helped solve this or we solved that. But really what all we're doing is generating leads, and it is the law enforcement agencies that are solving the cases in the end. So let's talk about the process down into the genealogy. So of course, we're going to look at the ethnicity results for our subject. That will give us a really good idea of the regions that we're working with, the records that might be available to us. And then what we get really excited about is that big long list of matches or relatives who share DNA with our unknown person. So I'll focus on GEDmatch, but we use the same strategies at Family Tree DNA. If you've worked with GEDmatch at all, you're used to seeing a specific kind of screen. There's a lot of green in there. When we're doing IgG work, we're working in GEDmatch, but we're working in one called GEDmatch Pro. So it's a separate portal, separate website that we log into, and it's got blue there, so it looks a little bit different, but that's how they're separating out the law enforcement side from the public side. We see a lot of the same sort of information. So when I'm looking at the list of people who share DNA with my unknown person, I would see it here. And this is quite fuzzy. I've anonymized everything here, so you won't be able to actually read the details here. But each row in that table represents a person who shares DNA with my unknown person. So we'll see things like the unique kit numbers for every single DNA match. We will see whatever name and email address they've uploaded. Sometimes people are using aliases, sometimes they use initials, which makes things a little bit challenging, but it's understandable. we will see the amount of DNA that they share with our unknown person. And that is obviously going to be very important to us as we move forward. In the middle of our table there, we will see there's an empty column. And that column is just telling us whether or not they've included a family tree. So we like to see something in that column. It's always nice if somebody's uploaded a family tree with their DNA sample. Most of the time, we're not seeing any family trees in there. If somebody includes a family tree, we take it with a grain of salt because we often will see some mistakes in there, but it can be a really good start for us and some really good clues. So if you want to help with IgG work and you upload to GEDmatch, please consider including a family tree. And if you're worried about privacy, you don't necessarily need to include yourself or even your parents, even your grandparents. If you include a family tree that starts at your great-grandparents, that's a good start for us. If you're comfortable including your grandparents, that's even better. Whatever your comfort level is great. So this table is really several thousands of rows long. We have thousands of matches in there. Most of the time we try to focus on the higher matches, but we do dig down deeply sometimes when we need to. So what do we do with this big, long list of unknown people? We don't know who any of these matches are. How do we figure out who our unknown subject is based on this long list of people? So let's simplify this a little bit, and let's just imagine that we're working with the top 6 matches. We're going to focus on those top 6 matches and try to figure out how our unknown person relates to them and how they might fit into their family tree. So the one thing that we want to try to do is make some sense of these long lists of people. Now we'll start by trying to group these people into what we call clusters. So in this example, we have 6 matches, and we'll group them into 2 clusters. We have matches 1, 4, and 5 in the left-hand cluster, and we have matches 2, 3, and 6 on the right-hand cluster. They group together because it turns out I can use the tools at GEDmatch to see that matches 1, 4, and 5 share DNA with each other. And I can also see that matches 2, 3, and 6 share DNA with each other, which means that matches 1, 4, and 5, if they share DNA, they are related in some way to each other, which means that theoretically they all descend from the same common ancestors. And I can go further with that and then theoretically say that my unknown person probably also descends from the same set of common ancestors for that group on the left. The same thing applies to the group on the right. So that's what we're trying to do, is we're trying to group our matches into groups that share DNA with each other. And then we want to figure out who those shared ancestors are. So once I've identified groups of people who share DNA with each other, I'll focus in on one of those groups. And that's where I start doing the traditional genealogy. We start doing our tree building, which is the fun part for most of us. So I'll start with matches 1, 4, and 5, and we start building trees. Sometimes we get further with some trees than we do with others, and that's okay. But my goal here is that hopefully I'm going to find a set of ancestors that is common across all 3 sets of these trees. So with any luck, I'll see a couple that repeats across these trees, which means that matches 1, 4, and 5 all descend in different ways from that ancestral couple that is circled in yellow there. So that is our goal. From there, what I want to try to do is simplify this a little bit, because now what I'm theorizing is that if all of these 3 people descend from that same couple, theoretically my unknown person does as well. So for now, I'm going to remove the gray people. They're important for sure, but they're not part of my project for now. So we can remove the gray people and redraw this tree in a simplified format. So now I have direct lines for matches 1, 4, and 5 leading up to a set of shared ancestors. And again, hopefully my unknown person descends from the same set of ancestors. And then we do the same thing for the next cluster. And we find a second set of shared ancestors that our unknown person potentially also descends from. So this is great. We're making some progress, but how do we figure out who our unknown person is? Now what we need to do is something called descendancy research. So we start with our ancestral couple at the top of the screen there, and we want to look at all of their children and all of their children's children and their children's children until we get to a level where we think our unknown person was born. That unknown person will be one of those descendants. So we start doing that descendancy research. But we can make this a little bit more efficient because we know that our unknown person relates to both of these clusters. So there's got to be some kind of connection between those two clusters. And hopefully that connection will be in the form of a documented marriage. It's not always, but hopefully that's what we will find. So hopefully there will be descendants from those two clusters who have married and had children. And our subject will potentially descend from what we call a union couple. So those two descendants that marry would become our union couple, and they would have children and grandchildren, and our subject will be somewhere down there. Our subject could be potentially their child. Our subject might be their grandchild or maybe their great-grandchild, but we are getting closer. If that's as far as I can get, that is great leads for the law enforcement agency, and they might be able to get further with that information. But that is the essential strategy that we're working with. So let's use that strategy and look at the first case that we worked with at BCIT. So BCIT was really excited to try out IgG, and they're always working and experimenting and pushing boundaries. So in 2022, they decided that they'd like to try this out. They chose a case that at the time was 5 years old. It was a cold case. It was unidentified human remains, so there was no criminal aspect to it. There was an elderly gentleman who had passed away in downtown Vancouver in front of a church that is pictured there. While people knew of him and had seen him around for many, many years on the streets and knew that he was a homeless person there for a long time, nobody knew his name. And so the coroner's service was never able to reach out to family to let them know that he had been found deceased. So they figured this would be a really good case to begin with, and they had some good quality DNA samples, and we moved forward with that. So BCIT at the time uploaded the first set of profile to Family Tree DNA. And we also had plans to upload to GEDmatch, but at the time we had a few hurdles to jump through. So we had to wait for the GEDmatch results for quite some time. The Family Tree DNA results, the first thing we looked at were the ethnicity results, which suggested that this person was predominantly of Western and Central European descent, had about a quarter Southern European descent with a tiny bit of Baltic in there. This was promising, just in terms of records that we would be working with, so we felt confident with that. The next thing that we looked at were the list of people who shared DNA with our unknown person. And so obviously we're hoping to find a really close match. So I've anonymized the next screen for you, and I'm just including numbers instead of the names of people. And it's the top 10 matches that our unknown person had. If you've worked with DNA, you'll have some ideas in your head about the numbers that we would have liked to have seen. Here is the list of top 10 matches for our unknown person. And our top match, our closest match, shared 75 centimorgans with our unknown person. We were definitely hoping for a higher number than that, particularly for our first case, but we figured we're up for a challenge. We're going to work with that. If you have not worked with DNA before, I'm going to give you a little bit of a backgrounder on what a number like that means, so you have a bit of context here. So let's take a quick look at a really small example family here. We have a father, a mother, and a daughter. That daughter will share 3,500 centimorgans of DNA with her mother. So centimorgans is the unit of measurement that we're using most often to denote how much DNA is shared between two people. So you will share a roughly 3,500 centimorgans with your biological mother, and you'll share the same amount with your biological father. That is a very clear relationship. If you see that in your DNA test results, that match will be either a parent or a child to you. But as we get a little bit more distant in our relationships, those numbers go down. So full siblings who share the same parents will share roughly 2,600 centimorgans. If you see a DNA match with 2,600 centimorgans, that is very clear that that is going to be a full sibling. But as I said, the numbers go down. As the relationships get more distant, the numbers go down. So this father may have had a son from a previous relationship. That son on the left is then a half sibling to the two children in the middle. So half siblings will share roughly 1,800 centimorgans with each other. But this is where things start to get fuzzy, because if you see a match in your DNA list of relatives that shares 1,800 centimorgans, it could be a half sibling, but it could also be a couple of different types of relationships. Let's introduce the grandmother here. She shares 3,500 centimorgans of DNA with her son, but she shares roughly 1,800 centimorgans of DNA with her grandchildren. So 1,800 centimorgans could mean a half sibling, but it could also mean a grandparent. It could mean an aunt or an uncle. So this starts to get a little bit fuzzy here. And as the numbers go down, the potential relationships that correspond with that number increases. So we have a really useful tool called the Shared Centimorgan Project. And what we can do is we can type in whatever number we're interested in the little box at the top of the screen to see what relationships might correspond to that amount of shared DNA. So in this case, I would type in 75 centimorgans to see what that potentially means. And that tool will tell me, well, somebody who shares 75 centimorgans with you, that person could be a half second cousin, could be a second cousin once removed, it could be a third cousin, it could be a fourth cousin. There are lots and lots of types of relationships here, and they're all quite distant. So 75 centimorgans is a fairly distant match. It's a bit lower than we would definitely like to work with. But what I do know is that that top match is not going to be an aunt or an uncle. It's not going to be a first cousin. So I do know that when I start building the tree for that top match, I should go back to at least their great-great-grandparents, if not their 3 times great-grandparents, as I'm building that tree, because that's probably where the shared ancestors will be for our unknown person. So we knew we'd have to wait for a little bit for the GEDmatch results. So we thought, let's give this a shot and see what we can do with these low numbers. And we had some success. So working with matches 1, 5, 8, and 29, we found that they all shared DNA with each other. And as we built back the trees, we found a common ancestor. And I've anonymized the names, I've made up names here. I have David and Sarah Blue at the top there, and they were born in the late 1700s in Ireland. So this was our first cluster. And hypothetically, our unknown person who had passed away, he was also a descendant of David and Sarah Blue. We just didn't know how yet. So we worked with additional clusters. We had another set, matches 3, 58, and 74, and those were getting quite distant, but we found they shared DNA with each other. We built back their trees. We found a set of common ancestors. I've named them John and Mary Red. They were born in the late 1700s in New Jersey. And then we had another very small cluster of just 2 people that they led back to a shared ancestor. In this case, I've called him Ed Gold. He was born in the early 1800s in Ireland. He married twice, and these 2 descendants descend from each of his wives. So they're all quite distant, small clusters, but we thought this is something that we can maybe work with. So now what we want to try to do is our descendancy research. We have some ancestral couples. We want to work our way down. Of course, way back then, people had a dozen children easily. So we knew this would be a lot of work. And that's okay. We love a good challenge. So we worked our way down from these ancestral couples, and we found that Ed Gold had a female granddaughter, and we found that David and Sarah Blue had a male great-grandson. And they were in the same community at the same time, and yay, they got married. There was a documented marriage for these 2. This was really great news. And we got very excited. But of course, this couple had about 12 children at the time. So we knew it was going to be a lot of work working our way down for each child to figure out where our subject might fit in. But before we could work our way down from this union couple, did a little bit more work here and found that that's just showing where our subject might be. We weren't sure yet. But it turns out that female gold had a sister. And the blue great-grandson, he had a brother. They're in a small community, and as often happened back then, there's a lot of intermarrying. And so in this case, we had two sisters marrying two brothers. This is not great news. It means that I have two union couples, which means my work is effectively doubled because I don't know which union couple my subject might descend from. He could descend from either one of those couples. So now I have 24 children to look at and all of their children's children, etc. But it did not stop there. There was a third gold sister. And when I present this in the past, people always say, oh, she married a third blue brother, and she did not. But she did have an illegitimate daughter. And so when I saw that, I thought, oh no, who is the father? And what was really remarkable about this woman is that she raised her illegitimate daughter, and this was, I think, the late 1800s or early 1900s. So she kept her daughter, which is incredible. She raised her, but she never said who the father was. So all of the records for that daughter, where a father should be named, it was always left blank. And it seems to have been a big family mystery. So of course, I could not rule out the possibility that the father was a blue brother, which would mean a third union couple. So we dug deeper into the DNA, and I was able to determine that, yes, in fact, the father was a blue brother. I don't know which one, but I know that it was one of the blue brothers. So I couldn't rule out the possibility that the illegitimate daughter was potentially an ancestor of my subject. This was actually kind of welcome news because she's our third union couple here, but she only had one child. So in terms of prioritizing my research, I'm going to focus on the couple that had the fewest children, and that was the one who had the illegitimate daughter. So I worked my way down with the illegitimate daughter, and
Yeah.
turns out, and this starts to get kind of messy, it's a little bit difficult to include everything in here, but the illegitimate daughter is the green box on the right. And it turns out that she married a descendant from the red cluster, which connects in our red cluster into the yellow and the blue clusters, which is what we want to see. Now, I couldn't rule out the possibility that descendants from the other two union couples, perhaps they married descendants from the red cluster as well, but we were starting to feel pretty confident about this and thought it's definitely worthwhile looking at the illegitimate daughter and her descendants, and maybe our subject is one of those descendants. So at this point, we felt confident moving forward with this. We felt pretty confident that we would potentially help solve the case at this point, but this is when the GEDmatch results came in. So the GEDmatch results arrive. And the first thing we looked at were the ethnicity results, and GEDmatch uses slightly different regions and naming, but essentially what we saw there mirrored what we were seeing at Family Tree DNA, which was good news. Here are the results from Family Tree DNA. Remember, our top match was 75 centimorgans, so we're hoping to see a higher number at GEDmatch. And the top match at GEDmatch was 953 centimorgans. This was mind-blowing. I thought it was a mistake to begin with. And I have never seen a number that high in any of the cases that we've had since then. But this was great, great news. And if only we had those results to begin with. But still, it was a really great process for us to work with the Family Tree DNA results to begin with. So we type in 953 centimorgans into the shared centimorgan project, and it tells us that top match could potentially be a great-grandparent or great-grandchild. Given the ages of these people, that didn't appear to be a good possibility. Could be a great aunt, it could be a first cousin. So we knew that when we built that top matches tree, we didn't have to go too far back, maybe just to the grandparent level. Now, There were some issues with that person and their tree. There are always some curveballs when we're dealing with GEDmatch. It wasn't as straightforward as we'd hoped to build out the tree and figure out who her ancestors were, but it wasn't as much of a challenge as the family tree DNA results. So we were able to identify her grandparents, and it turns out that her grandfather married a child of our illegitimate daughter from the green cluster there. So she tied it. It turned out that top match was a half niece to our unidentified person. So when I saw that her grandfather married into all of the work that we had previously done, I just did a Google search on the names of that grandfather and his wife. And I found things like obituaries that named all of their children. And they actually had quite a few children. So I was most interested in the sons' names. And when I started Googling the sons' names, most of them seemed to be alive and well, but one of them popped up in a really interesting book. So in the early 2000s, there was a book that was published about homeless people living on the streets of Vancouver. And what they did was interviewed a number of homeless people. They took photos of them and they included a biography and an interview for each of these people in this book. When I Googled the person's name from the obituary, this is what came up. And it was a fairly unique name. And I saw his photograph, and part of his quote in there said that he had been wandering up and down Granville Street waiting to die, but it has not happened yet. And it turned out to take another 15 years or so for that to happen. The last thing he said in this interview was, don't do drugs and don't come and live on the street. People should be someone. And when I read that, it just broke my heart, because he essentially died a no one with no name. So we send all of this information back to the coroner's service. They compared the photograph with the postmortem photograph that they had for him, and they felt very confident moving forward and reaching out to his family. So they reached out to one of his full sisters, and she agreed to do the traditional DNA test, which was the STR DNA test. So she did that DNA test, and they compared that to the original sample that they have, and it was a match. And so that was, in fact, the correct person. So it was a really, it's actually a very sad ending, because these cases are never happy endings, but it was really meaningful to be able to provide that family with information about their lost brother. So challenges that we have in IGG, well, as I mentioned, we only have access to the smaller databases. That's a really big challenge. We hope to see those numbers grow. As those numbers grow, our odds of finding close DNA matches increases, and we're able to solve more cases, and we're able to solve them more quickly. One of the big challenges that we have are the underrepresented populations in the databases. So most of the people who have taken a DNA test have Northwestern European ancestry. So if our unknown person has the same ancestry, we have really good odds of finding close matches. But there are a number of populations that just don't have good representation, because they haven't taken, not many of them have taken DNA tests. So groups like Indigenous groups, African American, Hispanic groups, it's very difficult. Those become much more challenging cases, just because we don't see as many of them in the databases, and so the matches tend to be quite more distant. The quantity and the quality of the DNA sample is definitely affects with the success of this work. Family trees, especially when we're working with GEDmatch, most people tend to upload to GEDmatch because they have some kind of challenge in their tree. So we have a lot of complex issues. We have illegitimate children. We see adoptees in our match list all the time, complicated family trees, endogamy, you name it, we see it. Every single case has challenges. And I'm sure that if you've done genetic genealogy, you have run into your own fair share of challenges. Lack of genealogical records depending on where we're working, and funding. Funding is a really big issue. So Ontario has had a huge grant that allowed them to cover the costs for processing lab samples, uploading to the genealogy databases, paying for genealogists. And a result of that is they've been able to solve dozens and dozens of cases, which is just incredible. In BC, we haven't had nearly the same kind of funding, so things have been much slower, but we're hoping to see a change in that this year, and I'm feeling really confident that we will be seeing more and more work. So that is a really big issue as well. The last point there is last summer, Ancestry changed their terms of service in quite a big way for our industry. Ancestry has never allowed us to use DNA results, and we've never uploaded to Ancestry, nor have we been able to. We've never used DNA results for matches at Ancestry. But we have in the past made use of their family tree building software. We've made use of the billions of records that they have. Last summer, they made a change in their terms of service saying that law enforcement is not allowed to make use of the trees or the records at Ancestry. And that was a really, really big blow to our industry. We can still use other databases to find similar information, but sometimes it's not as quick and easy as it can be at Ancestry. So that was a really big blow. How you can help, do consider taking DNA tests or testing the older relatives in your family. Upload to GEDmatch, Family Tree DNA, or DNA Justice, but do read the terms of service. Not everybody is comfortable with this, and so we need to respect that. And I'm certainly not saying everybody has to do this, but if it's something you're interested in and you're comfortable with those terms, do consider uploading. You can opt into or out of law enforcement at any time. You can change your mind daily if you want. If you opt out at Family Tree DNA, we will never see you for any of the cases. At GEDmatch, it's a little bit different. If you opt out at GEDmatch and we're working on a criminal case, we will never see you. If you opt out, but it is an unidentified human remains case with no criminal aspect to it, we will still see your results if you match with our unknown person. That is very clearly written out in the next to the checkbox of opting into or out of law enforcement work. Do consider adding a family tree to your results. As I said, we do run into lots of mistakes and errors at times, as I'm sure you have when you're doing your genetic genealogy, but it's definitely a great help for us if we could see that. And if you're interested in getting into this kind of work, start by building your family trees, taking a DNA test, see what you can do with your own results, see if you can solve some mysteries in your own family tree or for some relatives or friends. Upload your results to GEDmatch and Family Tree DNA and get a sense of the tools that are available there. Try to assign yourself a mystery in your family tree to solve, but only use the tools at GEDmatch and Family Tree DNA. There are lots and lots of free online resources and webinars to help teach you on how to use these tools. I've included a lot of that in the handout. There are tons and tons of educational opportunities out there. And if you have time, do feel free to get in touch. I love talking about this. I'm excited to see this move forward, and I'm really, really excited to see lots and lots of cases that were previously unsolved get solved. So if there are questions, I am happy to talk through them now.
I have a question about criminology. Do current inmates who, when they are apprehended, get fingerprinted, is their DNA now collected at the same time?
That's a really good question. I can't give you a definitive answer because I'm not law enforcement, but I think depending maybe on the crime or maybe all crimes or where you live, that it is often the case that a DNA sample is taken as well. I would definitely have to look that up just to be sure if it depends on the crime and the severity of whether or not that happens all the time or not.
And the second question about that would be somebody like an organization like our military, do they keep DNA samples on those participants' file or whatever, so that should they be killed in action or on assignment or something, would they have that collection too?
That's a great question. And as well, I don't know. It's a good question and I'm going to look up the answer, but because I'm not military, I can't answer, unfortunately. But maybe somebody else here who is military might have an answer.
Well, thanks for your presentation. It was really mind-boggling.
Thank you.
Further questions for Marie? Very quiet group.
Well, I might have run over a little bit, and I know you had a long meeting beforehand, so I totally understand.
I do have one. Um, I've done a lot of research in where we have families that intermarry within each other. So it skews our DNA results because you got first cousins marrying first cousins and then their children marrying each other. Um, have you come across that? How does it affect some of the research that you do in these cases?
Yeah, we definitely come across that, not only with our unknown samples sometimes, but with the matches that we're dealing with. So that is always a challenge, and I'm sure a lot of people have run into that. As I mentioned, my mother is French Canadian, and so there's a lot of intermarrying that happened there. And what we would call that sometimes is endogamy. And that can, because you have that sort of intermarrying or cousins marrying cousins, in a way, it inflates the amount of DNA that you're sharing with matches. And so when I'm using a table like the Shared DNA project, those numbers might not be as realistic or dependable. So we have to be really careful about that and use other strategies in terms of looking at the DNA much more closely. So we're looking down into the segments of DNA. When people are sharing DNA with each other, often they will share it in a number of different chunks or segments. What we're hoping to see are larger segments, and then we're going to focus on those larger segments because they'll be a little bit more trustworthy than the small segments. Sometimes if we're dealing with a really challenging population like that, what we can do, we try to avoid this, but what we can do is called reference testing. So if we've identified a family of interest, but we really don't quite know which line to focus on, we can reach out to living people in that family and ask them to take a DNA test. So I wouldn't do that myself personally, but I would make a recommendation to the law enforcement team to say it could be very helpful to get some additional testers here, which will help narrow the lines because it's a bit of a mess right now. So if we can test 3 or 4 people here, some of them will be more closely related, and we can then focus on those lines and work our way down. So we call that reference testing. We try to avoid that as much as we can because it can be upsetting for people to get a call from law enforcement and say, hey, would you be willing to do a DNA test for us? So we're very, very careful about that sort of thing, but that's definitely one of the approaches that we could take in those sorts of cases.
Thanks. Lots of compliments, Marie.
Oh,
Great.
thank you.
And I just want to mention to everybody that the handout is posted in the chat. If you want to download it, it is there for the taking. And the rest of the comments are all great presentation. Everybody enjoyed it. Any questions?
I'm just looking at a couple of the comments, and somebody may mention Nathan Dillon Goodwin's books. If you haven't read his books, they're excellent books. He's got a set of series that's more just focused on traditional genealogies. They're fictional books, but they're really great, and they go into depth about the genealogy and how this detective solves mysteries. And then he's got a set that focuses specifically on IgG, as Jill mentions here. And he goes into great detail on exactly how they do the work, but in a really fun and exciting way. So if you're interested in this, definitely have a look at that. I think I've included that in my handout, but if I haven't, thank you, Jill, for bringing that up in the comments. I have all of his books. They're great.
All right. Anybody else? All right. Well, thank you very much, Marie. A lot of information to learn and to digest for us, so that's great. If there's no more questions, we will close the meeting for the afternoon. Take a look at the handout that Marie has prepared, and as she said, she's left her email address there, so get in touch and have a chat. So there's lots of stuff to investigate here, so there we go. Thank you,
Thank you so
everybody.
much for having me.
Thanks. We'll be in touch.
Okay.